Hi, Dr. Rizwan. I'm from Group 8 and my group consists of 3 members which include Yee Shing, Christine and me, Sook. Our group are going to explain the solution for question 3 and question 8. For question 3, a roller coaster in figure 3 with a mass of 200 kg is launched at point A with a speed VA that is just sufficient for it to round the top of the loop at point B without leaving the track. The radius of curvature at B is rho B equal to 25 meter. A. For the coaster to not leave the track at B, the normal reaction at this point is 0. Give your opinion why is this the case. B. Solve for the height h the coaster car will reach at point C. For part A, the opinion will explained by Christine and I will explain the solution for part B.
A. For the coaster to not leave the track at point B, the normal reaction at this point should be 0. Before I give my opinion, I would like to explain about the free body diagram and the kinematic diagram for the coaster at point B. At point B, the free body diagram and the kinematic diagram is as shown. The weight and the normal force and the normal reaction are all pointing downward. So, to explain my opinion, I would like to use Newton's second law, which is the summation of force is equal to mass times acceleration. From Newton's second law, we know that summation of force is equal to ma. So, based on the free body diagram, weight plus normal reaction is equal to ma. So, at the same time, weight is equal to mg. So, mg plus n is equal to ma. So, move the mg to the other side, we got n is equal to ma minus mg. We know that the normal acceleration is equal to velocity square over rho, where rho is the radius of the circle. So the formula we get is n is equal to mv square over rho minus mg. So with this formula, let us consider when mv square over rho is lesser than mg. At this case, after we substitute the value in the formula, we will get n is negative. When n is negative, the coaster will fall down. This is because the resultant force is pointing downward. So, therefore, to prevent this from happening, the normal reaction is set to be 0 to give a minimum velocity for the coaster to pass the top of the roller coaster without leaving the track. So the derivation of the formula can be seen as since the normal reaction is set to be 0, so 0 is equal to mv square over rho minus mg. So v square over rho equal to g, v is equal to square root of g times rho. So with this, minimum velocity is calculated for the coaster. The coaster will be safe to run is because the coaster won't leave the track. So in my opinion, this is why for the coaster to not leave the track at point B, the normal reaction is 0.
Hi, I'm Sook and now I'm going to explain for part B. Solve for the height h the coaster car will reach at point C. To determine the height of the roller coaster car will reach at point C, we will first draw the free body diagram and the kinematic diagram. Free body diagram is used to show the relative magnitude and direction of all forces acting upon an object in a given situation. Free body diagram is a special example of the vector diagrams. For kinematic diagram, it illustrates the connectivity of links and joints of a mechanism rather than the dimensions or shape of the parts. This is the free body diagram and kinematic diagram from figure 3. This is the weight of the roller coaster exerted, and this is the normal reaction force, and this is the kinematic diagram. Then we will use the equation of motion to obtain the velocity at point B. Equation of motion is when a particle moves along a curved path which is known. The equation of motion for the particle may be written in tangential directions, normal directions, and binomial directions. This is the equation for tangential directions. This is the equation for normal directions, and this is the equation for binomial directions. For this case, we will only use the equation of normal directions, which is summation Fn equal to MAN, which AN equal to V square over rho. Summation Fn always acts in the positive n direction. Hence, AN represents the time rate of change in the velocity's direction. This is the equation of motion. We assume the direction points downward as positive. Summation Fn equal to MAN, and summation Fn is equal to W plus N. Then we will elaborate the equation and substitute the value given from the questions. Then finally, we can obtain the velocity at point B, which is equal to 15.66 meter per second. Then, to find the velocity at point A, we can use the principle of work and energy. The principle of work and energy shows how the work affects the velocity of particles. In general plane motion, this equation states that the sum of initial kinetic energy, both translational and rotational, and the work done by all external forces and coupled moments equal to the body's final kinetic energy. And this is the equation T1 plus work equal to T2. The weight of the roller coaster, car, and passengers do negative work since they act in the opposite direction to the displacement. When the roller coaster travels from A to B, we have TA plus work equal to TB, and we elaborate the equation equals to half mva square plus weight times changes in y equal to half mvb square. Then we substitute the value given in equation and the values we obtained before this, and finally we can get the velocity at point A, which is equal to 30.53 meter per second. When the roller coaster travels from A to C, it requires the car to stop at C, hence Tc equal to 0. For this situation, we also use the equation of principle of work and energy. Ta minus work equal to Tc. Then we elaborate the equation to half mva square minus weight times changes in y equal to half mvc square. Then we substitute the value we have, and finally we can obtain the height of the coaster will reach at point C, which equal to 47.5 meter.
Hi, my name is Yee Shing and I'm going to talk about question 8 for my assignment, which there is 40 kg of flywheel shown in figure 8 and has a radius of gyration of k equals to 0.3 meter about its center of mass. If it is subjected to a torque which m is equals to 9 theta half, where theta is in radian. So A, compute the mass momentum of inertia of the flywheel about its mass center, and B, calculate the kinetic energy of the flywheel, and C, determine the work done by the torque M. D, solve the angular velocity when it has rotated 5 revolutions starting from rest. We can see that flywheel is inserted between the supports. And for the first question, A, radius of gyration. What is radius of gyration? It is the mass moment of inertia of a body about a specific axis, can be defined using radius of gyration. And for the solution of A, compute the mass moment of inertia for the flywheel about its mass center. The mass is 40 kg and the radius of gyration is 0.3 meter. And for the formula we use I equals to mk squared, where the I is the moment of inertia and m is the mass of flywheel, k is the radius of gyration. After substituting the value which is given, then we obtain the value of 3.6 kilogram meter squared. For part B, we will talk about the kinetic energy for the flywheel. And what is kinetic energy? It is the energy stored mechanically in a flywheel. And when a rigid body is rotating about a fixed axis passing through point O, the body has both translational and rotational kinetic energy. The kinetic energy is expressed as the sum of its translational and rotational kinetic energy. Applying the formula of T equals to half moment of inertia angular velocity square. Then we substitute the value given. Then we remain the value as the symbol, as we didn't know yet the value of angular velocity. Then after that we proceed to the part C and D. Then after the part D we will substitute the value of angular velocity and we obtain the final answer. Part C, the question is talking about the work done. In order to calculate work, we're using the formula work equals to force times displacement. And for the question, since the moment is provided, we use theta and integrate the moment. Part C, determine the work done by torque M. For when a body rotates about a fixed axis, any point P in a body actually travels along a circle path, and the angular position of P is actually defined by theta. And the change in angular velocity, d theta, is actually called the angular displacement. It is with units of either radians or revolutions. They are related by 1 revolution is actually equals to 2 pi radians, and now we can see that this one is 2 pi radians per revolution. And from the given value in part D, which is 5 revolution, we actually obtain 10 pi by multiplying 5 revolution with 2 pi radian per revolution. And for the work done calculation, we integrate the moment, and we find the range of 10 pi is within 0 to 10 pi, since it starts from 0 angle. So after that, we substituting the value given, which is 9 theta to the power of half. After the further substitution and integration, we obtain the value of 1056.52 joule. For part D, we will talk about the principle of work and energy. What is principle of work and energy? In general plane motion, this equation states that the sum of initial kinetic energy, which both translational and rotational, and the work done by all external forces and couple moments equals to the body's final kinetic energy. For question D, we need to solve for its angular velocity when it has rotated 5 revolutions starting from the rest. We apply the principle of work and energy, which T1 plus total work equals to T2, which is the initial kinetic energy and the final kinetic energy. The initial kinetic energy is 0 because it is in rest, and thus left the equation of this. And after that, we substitute the kinetic energy which we obtain, and also the work done in the system. So this is the work done of the system, and this is the kinetic energy equation we obtained in part B. So after we substitute the value inside, we got the angular velocity, which is 24.22 radian per second. This is the end of our presentation. Thank you for watching. Hope you like our video.